Hello, everyone. Happy weekend. Hope your weekend is going well. Hope you are, I don't know when you're doing this, if you're doing this now or Monday or Tuesday, but this is all due by Tuesday at midnight, so hopefully you're getting to it before that. We are going to be working on Checkpoint 9. Now, Checkpoint 9, I have included the worksheet on here, but you do not need to print out this entire worksheet. In your packet, there should be one page titled Checkpoint 9. And that page looks very similar to, let me see, this page right here, okay? So find a worksheet that says Checkpoint 9, and you're gonna be, and it looks like this, and you're gonna be working on this worksheet for homework today. I am gonna do a little bit of this together with you, so I do want you to try to follow along. And if you do want to print out the whole thing, you can, but you do not need to necessarily take notes on it. I just want you to watch. Okay, so I know that's a little different than usual. I am just looking for the assignment worksheet. That's the only thing you need to show at this point, okay? All right, so one of the things we need to know is describing association, and we've talked about it before, but I do want to show you what we're looking for. We've got a set of data points like this one right here. You see this, and first of all, I want you to try to draw a line of best fit, and if you draw a line of best fit in this case, it looks something like that. It doesn't have to be perfect, but you see that line really shows the pattern of the points, okay? And when I describe association, there are four things I need to talk about. First of all, I need to talk about the direction, okay? The direction. And so I'm going to put direction. And the direction of this line here, if it's going up, is called positive. So this one's going a positive direction. Then I need to talk about strength. And remember, we talked about this before. Strength. How close are the points to the line, okay? And this one is pretty strong, so I'm going to go with moderate to strong. And so moderate to strong, I could really accept all of them. And actually, the first one, I'm sorry, I should have had is form. And form is how it looks. And if you look at this right here, this one is linear. So we have a linear, positive, moderately strong association. And then the last thing is outliers. Are there any outliers? And there are no outliers, okay? So that's just an idea of what we're doing when we're talking about describing an association. By the way, you're going to have to describe associations in just a minute, so be ready for it. Now I'd like you to think about this one. I'd like you to look at this pattern here and tell me what you think the association here is, okay? Now, I'm going to draw the line of best fit. I think the line of best fit looks something like this. Now, again, it's not perfect, but it should be pretty close. Will you please take a second and tell me the form, direction, strength, and outliers of this pattern here? Okay, form, direction, strength, and outliers. And I want you to look at the list right there. So what are they? Ready? Do you have it? Form. This is linear. Direction. This one is negative, and it's negative because it's going down. Form, direction, strength. This one is, let's go with moderate. It's not quite as close as last time. Moderate, and then are there any outliers? No outliers. Does that make sense? Good. Now this next page, I'm gonna be honest. This next page is kind of tough, but it's going to prepare you for what we're going to be doing here in a little bit. So I do want you to follow along here. Okay, we have the set of data here with time since purchase and hours and number of cookies. Okay, so we're talking about cookies and since we purchased them, so it's a little weird, but we're going to start graphing this data. That's the first thing I need to do. Now again, please remember when I make my graph. Okay, and this is X, or that was X, this is Y. The top value, the stuff on top, always goes on the Y-axis. It's your independent variable. It's what you started with, okay? So I'm going to go here and go with 0, and pretty much going up by, I'm sorry, did I say that one goes on Y? No, that goes on X. What am I talking about? So over here, the independent variable always goes on X. You can catch me on that. So I'm going to go here, and I know it's not a great fit, but I'm going to plot my points here. I know they only get to 10, which is not perfect, but with the amount of scores I have, that's really the best I can do. And this is time, and this is in hours. And I know I'm going over the bottom part there, but whatever. And then the number of cookies is going to go on the y-axis, okay? And I've got to go all the way up to 24. So counting out my squares, I figured out that what I could do is every square be worth 2. Now, I'm not going to label every square worth 2. I'm just going to go every 2 squares and go up by 4. Okay? So this would be 20, this would be 24, this would be 28. And as you see, my biggest number here is 24, so that should be fine. So now I'm going to plot my points. I've got 0, 24 right there. I've got 2, 20, should be right about there. I've got 4, 14, should be right about there. 6, 11, 6, 11. Now this is 12, so 11 would be right in the middle. 8, 5, should be put it right there. And then 10, 0. So I've got my points there. Now, as you see, they are definitely a pattern, but it's not perfectly linear, right? So here's where I'm going to draw my line of fit. So I'm going to go here, and I'm going to say if I connect this right here, let's say that right there works for my line of fit. Not perfect, but pretty close, okay? I'm connecting this point here, and I think like this point right here, okay? 8, 5, oh, actually probably not that point right there. Let's see if I can get a better point, because 8, 5 is not wonderful for that point there. It's a little bit above the line. So I think it's more like this point here. Now what I'm working on is approximating the data. It does not, well, doesn't have to be perfect. Okay, so let's now describe the association, and that's what we were talking about before, describing it. It is linear, it is negative. Do you remember what the others are? Negative, linear, strength. What is it? I'm going to say it's pretty strong. All the points are almost on it. And are there any outliers? No, no outliers. So that's what I put there. Then, draw a line of best fit. I drew it. Here is the challenge. Find the equation of the line of best fit. Now, we are going to get approximate values here, okay? We should be able to find the slope here because we're going through this point right here. And that point right there is, what was it? Again, this was 0.611. And it also seemed to go through point right here, 0.24. So if I know that, I can find my slope. Remember slope? Slope is rise over run. So how much did it rise to go from 11 all the way up to 24? It rose by 13. So my rise is 13. And my run to go from 0 to 6 is 6. So my slope is 13 over 6. Now, that is the exact number, and that's usually what I'd want you to go with. For today, I'm going to round that. Now, if I look in, I was wrong. Did anyone catch my mistake? What's wrong about 13 over 6? 13 over 6 would be going this way, and I don't want that way, right? It's 13 over negative 6. Now, in this case, I'm going to do some rounding here because we're just going to go with it, okay? So we're going to round. Usually we'd stick with this exact, actually, really, I could go with that and just say y equals negative, or 13 over negative 6, x plus, my y-intercept. Oh, nice. I've got the y-intercept right there already, plus 24. However, if you want to, and you might run into this problem in the work you're going to do on your own, I will allow you to do some rounding here and say this is y, and this is approximately what? This, we'll go with negative 2x plus 24. Now that's, again, a little bit pushing our luck a little bit there, but for today, I'm okay with that. Now they want us to use our equation to predict the number of cookies left after 5 hours. Would that the 5 replace the y, or would it replace the x? And if you look here, x is time, y is cookies, even though I forgot to label my axes there, it's cookies. So it's going to replace, after 5 hours, it's going to replace my x because x is talking about the time. So I go here, and y equals negative 2 times 5 plus 24. Y equals negative 10 plus 24, which means y equals 14. There'd be 14 cookies left, which is the answer to this problem right there. I know, I'm going through this really fast, and I appreciate you hanging with me, okay? I know it's not the most exciting, but thank you very much. Now, this is kind of the tough part here. This is another tough question here. It says, interpret the slope in context. What is going on here as far as talking about the slope? Now, my slope is this negative 2. And it's talking about how many cookies we've got here. These are the number of cookies that are left after time. And you see our cookies are running out because people are selling them. So what does -2 mean? -2 is my slope, and it means 2 cookies are selling every hour. They're selling 2 cookies every hour. That's why the number of cookies is going down every hour by 2. And then what is the y-intercept? The y-intercept is 24. What does the y-intercept in this situation mean? Well, look at it. Look at the graph. What does a 24 mean? 24 is the number of cookies that we started with. So if I can put it in here, come on, right here. 24 cookies to start. Good. So it's kind of combining the skills that we have that we've been doing all along. Well, your task is to finish this worksheet by doing the page that is in your packet that looks like this. It says checkpoint 9. Now I am going to tell you, and you can, if you don't find it in your packet, you can go ahead and print it out. That's okay. I'm fine with that. I am going to, let me see. I'm going to rule out a little thing here. I'm going to say you don't have to do this top question up here, these top 2 questions. And those of you watching the video, no, you don't have to watch it. If you didn't watch the video, you're going to try to do all of that, which is really obnoxious. So you don't have to answer those 2 questions. Here's what I want you to do. I want you to plot these points on this graph. You're going to plot these points on here, okay? Then you are going to answer these questions here at the bottom. Fully describe the association. Fully describe. Think of the 4 things we talked about. If you don't remember, go back and watch them. Draw a line of best fit and find the equation. Now, again, you can estimate this equation. If you get a fraction that's not quite nice, you can go ahead and round it to the nearest whole number, okay? And you can put that equation on here. Be careful when you plot your points. If they don't fit on here, your y-intercept might not fit. Just kind of throwing that out there. And which means you might have to extend your graph a little bit. So you can kind of extend your graph and make a prediction of where it would cross on your graph approximately, okay? So just letting you know that. And then you're going to use your equation. I do want you to use the equation to figure out how much it would be for a 6-year-old car. And then interpret the slope and the y-intercept in context. So that is your task. That's what I need you to do. That is your homework. That's what is due Tuesday by midnight, okay? If you have questions, feel free to check with me, and I'll be glad to help you out, okay? Have a wonderful weekend, everybody.